I'm here. I just stepped outside. I usually get here really early, and now I almost regret having stepped outside because it is beautiful out there right now. Like, oh my gosh. Such a nice day. You guys had a good week. Sorry I was out. I was theoretically, I was doing machine learning training. Really, it was here's Amazon's ecosystem of tools, and I mean, just touched on a whole bunch of different things. So it was pretty overwhelming for me. You're sitting in class all day and just, okay, go over all these different things. Yeah, just try and apply this. This is easy. So, what's that? We used Python, yeah, and they've got an environment called SageMaker that runs Jupyter notebooks essentially right in there. And then it was a little bit of instruction and a lot of just like, all right, just go do your own thing. We gave you some high level tips. And so there was a lot of being lost. Plus, my team in particular hasn't really worked on AWS at all. So we were struggling with all the little quirks of learning how to work in this whole different system. So pretty overwhelming few days, but yeah. Now we're supposed to turn that right back around and apply it into our product and build that stuff in. That'll go easy. So you guys had Daisy on Thursday, right? How did that go? Is that good for everyone? I believe she said she got everyone, I think pretty much everyone up and working GitHub, so they were able to get their code up onto GitHub correctly. Awesome.
I had trouble with this homework assignment getting it on GitHub. I think it was because we worked code from Daisy's repository. So then when I went to go git add and git push, then it gave me some.
Right. Okay. Okay. And what you guys did? The Jaden case example, is that the deal?
Yeah. To
start with? Okay, I haven't done that in quite a while. But yes, that's something that'll happen if you clone somebody else's Git repo. So there are, there's a lot of ways to deal with that. I guess after we go through this material, I can probably do something to show that. I don't want to interrupt this first, but really it's pretty easy to either change your remote or to set a new remote instance. And typically what you do is change it. So if you've cloned someone else's, then you're going to change what you're pointing to. And GitHub has a nice little workflow built into it to make that a little easier, because a lot of times I'll show you sort of both approaches at the end if you remind me. I can show you how to do both things, because if you're in GitHub and start from GitHub, there's a slightly easier workflow to follow. But if you clone somebody else's repo first, then each approach is just a little different. Any other issues or thoughts about Thursday? I know, yeah.
For Jaden's case, Daisy has set instructions to use the math method, and I just had to go time as how to use that. I was trying to attach a little bit to the function, and then I was trying to, because it was unclear when I was researching how to use it. So I think that the purpose of it is to bring that array without having to add like a variable right? So it was the green line, but
Okay. Yeah, we didn't use the map method very much in this class. So I can definitely, I'm thinking what might make the most sense there is I've got a series of short little videos I need to get up, and that's probably one that probably makes sense as a short little video explaining how to use the map method and where you would use it. You can use, anytime you would use map, you can use a for loop in place of it. It's just a sort of a more functional programming approach to that more concise, and you don't have to write out all the little details of a for loop. is basically what it does for you.
Is it faster too?
I actually think it's slower. I think in JavaScript in particular, it's actually slower to use map than it is to write your own for loop. But it depends on your case a lot. I mean, the speed difference you're going to see is so incredibly minor at any scale of what you guys would be working on. Right. So there's some sites out there that have test cases against some of this stuff, like, oh, we're going to try and do these in different ways, like a loop, typical loop versus a map versus a for each. So let me just check and see what it says. Although this is such a trivial case, it may sometimes, like, your browser can reduce it down to not the actual computation, so it sort of cheats, and then you don't get a good an actual comparison. So yeah, it looks like in this case, like, the for loop would have been faster as the fastest one, and then map was like 60% slower, and then this for each was even slower. And some of that is just because map is still a relatively new bit of functionality in JavaScript, and so a lot of stuff probably has an optimized code for using the map function, whereas over time there'll be more and more optimization for using the map function, and then it will probably speed up. Any other questions? That was good. Thanks for bringing that up. All right. As usual, if you're online, chime in so we can know that you're there. Get that jotted down. I know that a few of you said you were going to be remote today. And then today is sort of the introduction of a two-part set of classes for us. Today we're going to talk about software testing more generally at a higher level, and just what does it mean sort of to test software? What are the approaches that you need to take? What are the different ways that works? Might go a little fast, so there may be some extra time to go through some of these other things. And then I want to go over this to make sure, some of you may already be comfortable with these concepts of software testing, but I really want to make sure everyone's sort of on the same page, so that on Tuesday, might be Thursday, since Tuesday's remote, I may want to do it in person, but it's Tuesday or Thursday, we will be going over an approach to software development, which is known as test-driven development. And that's an approach to writing your software that relies a lot on tests to help you throughout the process. And so I want to make sure that we all get on the same page before we start talking about that. I also plan to be able to leverage this for some, I think, interesting assignments, the software testing portion, because I plan on being able to write some assignments where you guys will be writing tests and telling me where some sort of a function or a program doesn't conform to a specification. So you'll be writing code that does this testing against what we have. All right, so let's get started just talking about software testing in general. Like, what is testing of software? Again, this may be fast, but we've got a couple hands-on exercises, so we'll see how those go. But the idea is software to ensure that the results match the specification, right? There's nothing too complex there. Every piece of software, for the most part, is going to have some specification, whether it's written down or whether it's just been spoken. Hopefully, in a real formal environment, you've written down the specification. And testing is just making sure that that works. And there's a lot of different ways to accomplish that. There's no one way to test software. One important thing to know is it's usually, for most pieces of software that are more than a few lines of code, impossible to completely test a piece of software for all possible inputs and outputs. That's just, I mean, you can even, let's talk about a most basic example. If you have an function that takes two numbers and returns the sum of them, it's impossible for you to test every possible set of numbers on that, right? I mean, barring the fact that a computer obviously can only represent a number up to a certain size, but even then it would be really, really hard to test all of those cases in some way. So usually testing focuses on a subset, a targeted, a intentional subset of what you're trying to test for inputs and outputs. And that's some of what we're talking about is how do you determine that subset? What's a good way to figure out how you want to test something or the cases that you want to deal with. So in general, testing is broken down. I mean, there's a lot of different ways to break it down, but at a high level, when you're doing testing, there's two major categories of testing. There's what's the black box test. And this is testing where the tester has no visibility to the code, right? Hence that term black box. They don't get to see what's going on in it. They can only put something in and get something out. Off of a specification. They're testing, oh, they said that this is the specification for the software and that works. And I can't look at the actual code to know what I should test or how to test it. I can only test off this specification. It's usually done by somebody other than the developer. So on a lot of software development teams, you'll have testers who are just dedicated to testing the software. Their job is, here's the specification, here's the code or the program, run through it and test it. This can be done by code. You can write code that does this. Even with, for example, a user interface, you can write some code that will exercise the user interface that says like, oh, go find this element and click it. Go do this. And then black box testing, you're writing some code to do that. But the key aspect is you can't look at the code underneath to see what you should be testing. And usually testing a defect, since you can't look at the code, you need to report that defect in some way. You open a ticket, you with my team, okay, we were in these tests. We found this problem when it says that, let's choose division as a very simple one, right? Like the specifications by 0 should throw an error. And I divided by 0 and got 0 back instead. So there's something wrong with, that. I just know that here's what was expected, like input and output, and here's the result. And now somebody else needs to dig in the code, try to figure out what's wrong and how to solve it. Before I move on to white box, any questions, thoughts about black box testing? So we don't talk that much about black box testing in this class in particular, because obviously we're writing code, so we sort of get that visibility. Black box is a whole field where you can be a software test engineer, and your job is to write tests against code environment. So not all development is necessarily writing, the new application. There are companies that hire test engineers, and their job is oh, well, we don't have a good way to automatically test this portion, so we'll have to do that manually. But all of these things, we can write some scripts that will execute the code to test it for us. So if that's, you really love testing something, breaking it, figuring out, oh man, this was supposed to do this, but it didn't, and here's where it's gone wrong. That's just something that you enjoy. This is very much a possible career path in software development, is focusing on testing, writing tests, and just ensuring the quality of software, because that's a really critical aspect. So the other type of testing that you do is white box testing, and this one, obviously in comparison to black box testing, is the internal structure of the code is known. You know how the code is written, you can look at the code, that influences how you do testing. There is a third category, which is known as gray box, which is a little bit of a combination of the two. But since it's just sort of a combination, we'll focus just on these two in particular. So in white box testing, since the structure of the code is known, tests can be written to test specific paths in the code. In black box testing, all you can test is the specification. So imagine, you know, I mean, sort of trivial, but imagine you did have an add function. In black box testing, all you can test is, oh, if I give it 1 and 1, I should get 2 out. In white box testing, you'd be able to look at the code and potentially see that somebody had done something really silly, like they just did a whole bunch of if cases in there that said, if I got 1 and 1, return 2. If I got 2 and 3, return 5, right? And you'd be able to say, oh, I need to test all of these branches. Black box testing, you wouldn't really know how it was done inside of the code. In white box testing, you can look at it and say, I have to actually pass in these specific cases to make sure that that branch of the code gets run. Does that make sense? That's a lot of what we've been doing in a sense, sort of implicitly in this class, right? We've been doing some implicit white box testing where we have been, oh, I need to call my function with some inputs and just make sure that something comes out, but you also get to see your code. So you can know, oh, I need to test it with these inputs because I really want to test this portion of my code. Any questions on this? Thoughts? All right, so after we've talked about the two different types of testing, let's talk about different testing levels. And there's multiple ways to break down testing levels. This is just one common model, so don't think that this is the only terminology or the only approach. But there are many different levels that software can be tested at in terms of how much of the software you're testing. And that comes all the way from like individual functions up to entire programs or groups of programs together, right? So one of the most common ways that you'll see stuff broken down when you're talking about tests is what's known as sort of the test pyramid approach. And come back to why it's called the test pyramid in just a moment. But the test pyramid is, you've got unit tests at the base of this. And unit tests are these testing the tiniest isolated bits of function. Really small pieces. Then you've got your integration tests. That's testing connections of several things. And you've got UI or maybe end-to-end tests. And then it has manual tests up here at the top. The reason that this is usually written out as a pyramid like this is the idea that the higher up on this you get, the more expensive it is to run the test. It's a lot harder to run a test manually than it is unit tests, because unit tests are usually almost always their code that you've already written that run really, really fast. And so the idea here is that you should have more tests of the type at the bottom. So you should have more unit tests than you have end-to-end tests, because unit tests run really fast and test all these little small pieces. And then end-to-end tests are complex to write, complex to run. And so you want fewer of them, but they test a lot more of your stack all at once. And we'll talk more about each category on this right now, but are there any questions just on the test pyramid or the concept there?
Just as an example, a unit test would be like just making sure the integration test would be making sure the entire JavaScript file works. UI test would be actually going to the website and making sure it's good as opposed to doing.
Yeah, that would be great. So yeah, unit tests. What are you testing with a unit test? That's a great segue, right? A unit test is testing the smallest testable piece of an application. Typically, in most applications, that's going to be a function or an object of some kind. That's going to be the smallest thing that you can test. So most unit tests are focused on calling a function with some inputs and testing that you get the right output, or creating an instance of an object and then maybe calling a method on it and making sure that it works as expected. So those are your usual units that you're testing. You can't really if you think all the way back to some of the early exercises that I even had in REPL IT, you might notice that I didn't have that many exercises in REPL.IT until we introduced functions. And that's because it's hard to write tests that can test something that's not a function, because a function is a nice self-contained unit. So that's when the tests, and the exercises were able to expand and get easier or more robust. And the ones before that were very, very trivial, because that's a nice self-contained unit to work with. In unit testing, you're almost always doing white box testing. And that's because you need to know how the code is structured to test an individual unit. Because a lot of times at the higher level, you don't actually know what functions are getting called when you've got multiple layers of code. You just know that you're trying to take a high level action. That may run 20 functions. It may run 100 different functions. But in order to do unit testing, you need to be able to call those individual functions. So you need visibility into your actual code. And almost always, unit tests are written by programmers, and all right, let me check that. I do not know why it quit sharing. Let's try that again. That should be good. All right, looks like it. So almost always, unit tests are written on, unit tests are written by programmers, because they're actually code that you're writing that tests other code. And quite frequently, the unit tests are written by the same programmers who wrote the unit under test. So that's, if you wrote the add function, it's usually that same programmer who writes the unit tests for the add function. And that's because they want to ensure that before that gets into any code base that other people are using, that it's working correctly, and that they've got all of those cases covered for that small individual unit. And this is what we're going to be focusing on a lot more in the next class, is actually writing some of these unit tests. How do you write tests against units? And we will do some of it from scratch, where we're not using any sort of tooling. And then once we introduce leveraging NPM and Node modules, then we'll be able to use an existing library that will help us out a lot, so we don't have to do as much work for getting tests written. And question about unit tests? The idea? All right. Yeah, this is very conceptual today, very high level. So it's not going to be as much writing code right now as trying to think, again, trying to build those patterns of thinking. So I'm breaking this out into this building a pattern of thinking and then learning how to apply that pattern of thinking. So integration tests, oh, never mind, it does say sit, it's turned too fast. So integration tests sit between end-to-end tests and unit tests. These are typically testing the integration of maybe a couple files, or testing a whole file together, or testing, if you want to talk about a larger application, you may have integration tests that test that the code that is supposed to write to a database works correctly with the code that is the web controller that calls it. So you might test those pieces. Now, usually with integration tests, I haven't mentioned up here, but a lot of times you're mocking out still the layers outside of that integration. So with unit tests, you don't typically have to do that much mocking, because it's usually a function or a class, so you just set it up and then call it. With integration tests, since you still aren't including certain pieces of your application, like an integration test usually won't test the database itself, because that's something that will slow your test down a lot. So usually you'll have a mock layer, and don't worry too much about that. That's pretty much an advanced topic, but you'll set up basically like a mock database that acts like it's the real database, and use that instead of the real one. That way these still run fast, but they get to test some of these integration layers between bits of your code. And we're not going to get into these just yet. That's partially just because we haven't really been writing bits of code yet that are large enough to need integration tests. Most of our stuff has been small enough that unit tests will be more than enough to cover our testing needs. We probably get into some integration testing concepts when we start getting into the building out stuff with React and stuff along those lines. Integration tests since they live in between unit tests and end-to-end tests, they also live in between this area of white and black box. So some of them might be white box where you need to know the details of the code. You need to be able to execute exactly certain paths within the code, but some of them might be black box testing where you don't really know the details of it and you're trying to abstract that stuff away. I'd say more often they're white box. More often you know the details of your code when you're doing an integration test because you're usually having to create some sort of mocking or stubbing of some other portion of your code, but it's not always the case. Questions about integration tests? All right, so the last one we'll really talk about here is UI, or what's typically called like end-to-end tests as well. And the idea here is that's testing your product as a whole. So this is the one that is the more traditional role of a software test engineer, somebody who's working in a testing role on a team, is they're doing a lot of this end-to-end testing. Their job is here. I've worked on teams where literally they were just given the specification, and that might be a 100-page specification of the code and what it's supposed to do. And as a software test engineer, their job was to look at the specification, try and break it down into what tests do we need to make sure that all of this works correctly, and then work with us as the engineers to try and figure out how to accomplish that. Because as we talked about at the very beginning, it's impossible to test stuff completely, right? You're having to do some sort of spread. So for example, one of the teams I worked on did operating system installation software. So we had software that helped you install the OS on IBM servers. And that meant that it had to support all of this whole different range of servers and a whole different range of operating systems. Well, it was infeasible for us to test installing every operating system that we supported on every server configuration that we supported, because that was hundreds of server configurations and a dozen operating systems that you could install. And so one of the roles of the test engineers on our team was they would go and identify this stuff, look at the areas that maybe had changed since the last version of the code that were new, and they would create a giant test matrix saying, here's the scenarios that we intend to test or that we think will cover stuff. And then we would have a conversation to sort of back and forth, like, oh, I think this is really good. Now there's a lot of coverage in this area that we don't probably need because nothing changed there. So we can probably cut that down to just some samples and we'll feel comfortable with it. But this area over here, you're really missing. And we actually rewrote that component. So we need to have a lot more tests over there, right? And so it became this sort of back and forth conversation. But you notice it was that conversation because it was a black box to them. They don't get to know. In end-to-end testing, you pretty much never have the details of what's going on inside of the code. You're testing it as a black box. And your job is to just try and exercise it that way as much as possible. So this is the closest to what an actual customer is going to do when they're using your software, right? And this can be done, again, as I said, there are a lot of tools to automate this in different ways, or you can do it manually. But the concepts are pretty much the same, whether you automate it or do it manually of what you're doing, which is, let's say it's a UI product, then I want to click on this area. I want to input a value. I want to click next and move forward. And that script that you've written, whether it's automated or whether it's done by hand, is going to be the same process. Any questions or thoughts on end-to-end testing?
Is end-to-end testing still just internal, or is it beta testing, like strangers play around with it and try and break it?
So that's a good question. I don't know if there's a perfect answer to that. The majority of the time, you're going to want your end-to-end testing to be internal, and you're going to want to try and harden stuff. It depends on how, some of it though depends on how comfortable you are with a customer finding an issue. If you've got critical software, you don't want a customer to find, or for example, our OS installation stuff, that was like CDs, like that we had to stamp, or DVDs. And so we couldn't really put that out to customers very easily. So most of that was done internally. If you're comfortable with small errors or small issues, you may let customers do some of this. And that may end up with an approach where you have a different process, because you're not going to get reports from them of the same quality that you would get from somebody whose job it is to test. So if you are going down that route because you're like, oh, it's okay if we have some issues in this space, but we want to know about them, then what would happen is your software development team is going to have to write some control, some logic into the code itself that will help with that. So you may have some code written into the application that says, oh, if an error happened in this area, then log that back to our server so that we can know that people are encountering errors there, and give us as much detail as we can get so that when the customers are using this, you know, if that's what we're doing is it's sort of a beta mode, we'll be able to go, oh yeah, we're seeing a bunch of errors in this area. There's probably a bug there. We want to do some more testing on that side to try and identify it. Now, usually you're not trying to leverage external customers for something like that. But even if you did end-to-end testing internally, those types of things can get out. So it's a good idea when you're actually writing production-facing code to have some way to get reports back of errors so that you can try and debug them or notice if there's a whole bunch of errors happening in some context. That was a really good question. Any other thoughts about end-to-end testing questions? All right, so as I said, for this class, we're gonna focus mostly on unit testing right now. And then the other ones, maybe we'll dabble in later on, but we're not going to focus too much on those because those are a much higher level concept, and we're committed more to teaching programming versus teaching, you know, the test engineering level of stuff. So let's work through basically the rest of today. I want to try and work through a couple examples of how you would go about writing tests, or at least defining what your test specs would be for some stuff. So the goal with unit testing is to test all of the specified behavior for a small unit of code in some way. For now, we're going to focus on the function as our unit to test because it's a nice, easy, self-contained thing. So it lets us talk about them very simply. We'll introduce objects in the future as something that we'll test as well, but functions are just the easier one to get started with. Where's my, let me double check here. All right. There we go. I just had my order out of order. So what we're going to start with is one example. We're going to try collectively to come up with tests that would be a good set of test coverage, a good idea for the zip function. If anybody's familiar with Python as a programming language, this idea comes from Python because Python has this built in. And that's the zip function takes two arrays and returns a new array with the items from each input array alternating. So here's an example. If it takes in an array of 1 and 2 and an array with A and B, the zip function would return 1A, 2B, right? The idea is it's like a zipper. It's like zipping them up, right? Putting them together. And then the other rule about how the zip function works is if the arrays are different lengths, then zip stops as soon as the end of one of the arrays is reached. It's still going to return whatever it was able to zip up. But, you know, again, imagine if you had a zipper and you've got one side that goes all the way up here and the other side stops here. Your zipper can't go farther than where the other side ends, right? It doesn't really make sense. And so that's basically what that says as a rule here. Does this make sense? Any questions about the zip function we're defining? This is the specification that we're going to be using to try and write out some. Today we're going to focus on just sort of plain English tests. And in the next class or future class, we're going to focus on trying to translate those into how we would write them in code so that we could have coded up versions of tests. So here's some of the things you want to consider when you're writing test cases for anything. Unit tests, whether this was, you would consider these, have these same considerations for integration tests, unit tests, end-to-end tests, but they'll apply in a different way, right? Is you want to consider any known edge cases that you can think of. What are the edge cases that might matter? So we go back to the division example we were talking about earlier, right? One of the edge cases of division is dividing by 0. Another edge case of division that you may not think of immediately is, what about 5 divided by 2? Does our specification say what to do if we would get back a fraction or a decimal? Or what about 1 divided by 3? What does our specification say about something that can only be represented as a fraction, right? Those would be edge cases in division that hopefully your specification says something about, that it says, oh, here's how you deal with that. If it doesn't, as either a tester or even the software developer, when you're thinking about writing something, you may be thinking about these test cases and thinking about those edge cases, and then you may have to go back to the business and say, oh, I was thinking about what I need to do to accomplish this, and I thought about these edge cases that we haven't defined behavior for, so we need to decide what that behavior is. Then you want to typically include some simple cases, you know, some of the straightforward ones. And then this is sort of goes along with edge cases, but think about what could go wrong and try and make sure that you're dealing with any consideration about what could go wrong. And we won't go too extreme with that because you could think of all sorts of stuff that could go wrong. Like one of the easiest examples of it that we'll sort of assume isn't going to happen in our case, at least today, is, let's go back to the division example. What if they passed in a string instead of a number? What if they gave me something that was an object instead of a number? How do I deal with it, right? That's a case of something going wrong. And if you were writing this out in, again, a company, you would probably have some specification. Oh, if one of my things is not a number, then throw the air of type air so that we know that it expected a different type than what it got. We'll sort of skip over those examples, at least for today, but they may crop up later. All right, so this sort of hands-on section. Let's go back and put the zip here. And I will come over here. Let's create a new file. It's a little larger. Minify this. And let's start just writing out what we think are good test cases. And one good rule as well that I don't have on here is when you're writing out test cases, it's a good idea to think about the concrete, especially when you're doing unit test level stuff. What are the inputs and expected outputs for this test case? But also think about how you want to describe that test case in plain English. What are you trying to test behavior-wise? Because when you're actually writing these out in code, a lot of times, your function name will be more or less the plain English description of what you want to be testing. So do you guys want to try and come up with some of these yourselves? You want me to just work through an example set of test cases for these first, or what? Me work through them? All right. So what I'll do is, look, I already have one example here, right? So I'm just going to use this. And what I'm going to say is, this one in plain English is something like, should return a single array containing all items from 2 equal length arrays. Something like that. I don't know. It's a little verbose, but I'm trying to capture this, you know, very much base case, right? And then what I could do is, even under that, I may actually have multiple test cases that I want to account for. So I've got the one that we already had. which is 1 and 2, and A and B returns 1, A, 2, B. Zipped up, but we could also have, we could even simplify it a little more if we wanted. 1 and A returns 1 and A, right? That's sort of dealing with, we could write some more if we want, but that's, you know, a good touch on these standard cases, these cases that make sense. Are there any that people think we should really particularly think about for the edge cases? Yeah.
Have 1 and 2 and A, and then it would just still return A if we call it 2.
There we go. Yeah. When, I don't know. I mean, I'm just writing these out. These names could be a little different, but when the first array is longer than the second array, return zipped array. You know, you could call it a lot of different things. You could put a lot of different definition up here, but return the correct zipped array or whatever, right? That contains all elements from the second array. And there's more to it than that, but it was like you have 1 and 2 and A, right? And that should return 1 and A. Because that's as far as it can go. Is this making sense so far? So this is the idea of what you would be doing with any sort of unit tests. And a lot of times it might be a little shorter than the full length description that I have up here for these, but that's a lot of times when you're actually writing tests, you're doing it very similar to this. So now, given that one, what about another example that seems very similar?
The first array is shorter.
Right, so we can flip that, right? Right, and that's, I mean, we could write it out in a lot of different ways. And a lot of times you might want to intentionally use different test data for your different tests just to help get some extra coverage too. So you may say, oh, this one will have hello world, and you know, flip it around a little bit, like we can do some prime numbers. It's 11 prime. It is. Something like that, right? And we could have more examples for each one as well if we want. So those are some of our edge cases. And as you think about stuff more, you will hopefully begin to think about what are the edge cases. Some of the other ones that are very much more reductive. If, let's say I don't yet know how to write these out, like describe them, but I'm just trying to think like, what would I get from different inputs and outputs? Is what happens if I pass in an empty array and this? That should return an empty array, I guess, because that's got all of the elements. That's as long as it can be, right? So that's sort of a reductionist case. And that's another one of those edge cases. So maybe I will put that underneath one. Returns an empty array, right? And then obviously, again, we can have the flip one. Returns an empty array. This could be 1, 2, 3. Empty array. Returns an empty array. So I don't know if other people are surprised, but that might be surprising that we've got at least 5 different types of edge cases that we pulled out of just that simple little zip specification in terms of things that we want to test. Can anyone think of other ones? I don't know if there might be. I'm probably missing some stuff that you'd want to test against, but
Mixed material array, like string.
yeah, I mean, that might be a good one, right? Works with arrays of mixed types, right? So make it real fun, right? Like here's, and to world and so that now it's even hard for us to quickly read, right? It should be 1, 2, hello world, the array 42, 100, and the array 24 and 13, right? A good test case because maybe you don't work correctly in that condition, right? And then obviously we've got the ones that I don't know if we need to. I was saying we'll pretty much ignore them, but if you were writing this out as a specification for production code, you're actually trying to test this, you may, depending on whether this function is something that can get called with code that you don't control, or if it only gets called by, if it only ever gets called by code that you wrote and control, you might make the assumption that it's only ever going to get called with correct values like arrays. But if it can get called elsewhere, you might say throws an error when the first parameter is not an array, right? And maybe you have like throws an error when the second parameter is not an array. So those are some of those at what can go wrong type conditions. And we're not going to, in terms of the code that we actually write, we're not going to write those cases for them, but we can at least think about what those end up being. So you could have like first parameter is hello, and throws a type error, right? And this is one that, even though you're thinking that's a little silly, you could easily make this mistake because, for example, if you used for loop and got the length of the inputs of each input item and stepped over them, then this hello string would work just like it was an array with 5 items. So your code wouldn't realize that it was a string, and you may have that bug in your code. It's very possible for that to be a bug that you had, which is, oh, I treated this string like an array because JavaScript lets it act like an array and I didn't check. and now it intermixed stuff in a wrong way. So even though before you actually write the test, you may think, oh, why would I need a test for that? I can already think of how your code could easily have that bug in it. Any other thoughts, cases? I think this covers everything I was thinking about, but it's very likely I missed something too. We can go back and look at the specification too.
And that happens commonly.
What?
You try to think of all the cases possible. That's only when you start actually writing the code and testing it. Oh, crap.
Oh yeah.
Probably won't work in this case.
Oh, it's very common, yeah. That's why we'll talk about, and I'll give a precursor, but we'll talk about test-driven development in the next class. And the idea there is where you sort of flip the model. So here we're saying, here's a specification for this, and here's tests. And we would write these tests and run them against the code and make sure that it works. Test-driven development follows, sort of flips the script, and the idea is you write tests one at a time for code. So you know, if we were thinking about this code and we would say, what's the simplest bit of code that we could, or simplest test, like maybe this is like the easiest one, right? Like when the first argument is an empty array, it returns an empty array. Maybe that's the easiest one for us to code. So we might write that test, which fails because we don't have any code. And then we would write just enough code to have that pass, which literally might be like, oh, empty array, return an empty array. All right, we're good. Or maybe it even, the simplest code is it just returns an empty array all the time. It passes that case. And then you would start writing more tests that validate the other aspects of your code. But yeah, it happens all the time where you're continually going back and forth between the code and the tests that you're writing to say, oh yeah, I don't have any tests that covers this condition that I'm doing. Or when you're writing the code and you put in an if condition and you go, oh, I need a test to cover both paths on this if. Like those are some of the ones I probably should have put on that list of tips, right? Is when you're doing unit testing, when you're doing this white box testing, another tip is make sure that when you look at the code, any branch that your code can take, you have a test that covers each option on that branch. So every if condition in a function, you need a set of tests that cover it. And it gets really complicated when you nest if conditions, because if you have one if statement and then inside of that a nested one, you need a test case that gets you into this if statement and into the other one, and then a test case that gets you into the top level one and not the other one, and then a test case that gets you not into the top level one. So you need at least 3 test cases to cover all conditions in that. The more you nest, the more your tests multiply.
But another test for the zip function would be something along the lines of giving an error if what's returned is the first item from the second array followed by the first item from the first
Ooh,
array.
yes, that's a great test. The items should be mixed correctly or zipped correctly. Right? And that's sort of implicitly done with some of these, just if you wrote them and tested that output, but I think it's really good to capture that exact thing, right? So you would want to make sure, right, at one, returns not hello 1 world 2, right? So you want to make sure that they're coming back in the correct order. That's one of the fundamental aspects of it, and we sort of glossed over it, but it's a really good thing to make sure that you're thinking about and trying to cover. You know, you could have some that were, again, more simple, and that depends on what your specification is. So you may have some tests that say something like the input arrays should not be modified or something. And that's a harder one to test against, but you may have something like that, right? Like, oh, the input array shouldn't be modified. We want to get back a new array. That the level of testing that you might write on something like this would probably also depend on where this code lives. So for example, if this was something like the Python zip function that's going to live in the core of the language, then you're going to want a lot of tests that deal with all of these cases because you really need to know that it works correctly. Whereas if you're writing this for your program, you can probably make some assumptions at times that you don't need to test it as completely or all of these possible edge cases because it's only going to get called by your code and you sort of control how it's called. So you get to have some protection by just not invoking it with those possibilities. All right. See, look, we already came up with some that I definitely think we missed that were important. Any other ones that you can think of? All right. Let me save this real fast. I'll move where it's at, but so we wrote some tests for zip. Now let's go ahead and work at least one more. I thought I had another one on here. Let me refresh these. Do I have one more? Okay, good. One more example. Let's do this together. And then after that, I've basically taken a subset of the exercises that I had you guys do for, you know, what programming tools you would use to solve these problems. And I want you to work through what sort of tests you would write for those different, if that was a function that accomplished those things. So I'll show you that in a minute. But let's do some tests that we would try and write for array sorting. So let's say we have a sort method on an array, and this is the specification of it, and this is what we care about. We're going to keep it simple. We're going to assume that we only deal with string sorting in alphabetical order, not all the other complexities that can happen. But the idea is the sort method sorts the elements of an array in place and returns the array. The sort order is built upon converting the elements into strings. This is what I cut from something else. You know, it's assuming that it has strings. We're going to assume that the elements in our array are strings, and then doing their string comparison. So what do you guys think? What are some of the cases that we're going to want here for this sort method? And if you can't think of how to describe it, maybe we can just come up with a list of inputs and what the expected output would be, right? Because that's also a perfectly valid way to start thinking about your tests, is just start writing down examples of what the input would be and what the output would be. And then that might help you think about what a descriptive term is for that, right? If you have a fair number of those. So let's start with like one of these. Let's do some reductionist ones. So if we start with an array of, let me do it this, strings. That was my string. This is my array input. What would I expect my output array to be? What? A, right? All right, easy. What about this? That's my input. What do I expect my output to be? An empty array, right? Right. So we can start, some of these we can even put a name on, right? Like sorting an empty array returns an empty array. Sorting an array of one element returns the, same array. What's another, let's have one that actually, oh, I want these to be strings, I keep forgetting. So what should we get back for this? A, B, right? Sounds pretty simple. You think of some other examples that we can think of that might be relevant? What? Months of the year. Well, takes a little while, right? But it's a good test case, right? It's just a good bit of data, right? And it's okay on these as well to have a question after you start writing something out, right? Because I've got one that popped up as I started writing these out that I don't know if I felt was clarified in the specification. What do you think? Say this, and given that, we should get back something. But here's an interesting question that popped up as I'm looking at this is, should the case of the word matter in the sort order or not? Right? If I'm trying to implement tests around the specification, that's something that I would end up wanting to go back at this point and ask. Should the case matter or does it not matter? What do we want to do in our case? We can choose however we want to define this. It shouldn't matter, right? So it doesn't matter what the casing is. Sounds good. So what should we get back here? I will have to, people want to help me out, figure out the right order for this stuff. April, August. I think that's next, all right. January, June, July, or July, June. Oh, that's okay. That's an easy one. All right. February, January, July, June, March.
Will this come back in like first order?
What's that?
Will this come back in first order?
What do you mean reverse order?
It's like December around back in January.
I'm I'm not sure I get what you're asking.
So, there's something about sort, right?
Yeah.
Okay, so like, what would it be like, what would it find like, December, November, October, September, etc. First week?
It never-
Alphabetical order.
Well, we're sorting by alphabetical order. That's the only way we have to sort.
Okay.
At least in this case, that's all we have to sort with. So I think we've got that. I don't think there's,
Okay, so you can just sort. So you can
what's
sort-
that? What the? I do like my alphabet. I think that's looking right. I mean, that'd be a good test case, right? So we've got some good test cases that sort of cover the, the expected behavior, and we may want to write more of those. We may say, we want more of these test cases. But I would say both of these sort of fall under this idea of sorts as expected, more or less. Given an out of order list. All right, let's go back and look at this. There's some tricky bits in the specification for this one that we'll need to write some interesting test cases for as well. If you read the first sentence there, it's got some tricky things that we would want to test against, but that aren't obvious at first. What do you think it means when it says it sorts the elements of the array in place?
Your lines. So what would be out of place?
What would be out of place? Ah, good question. So what it means within place is it means that it's still the same array that gets sorted. So it's not, some versions of sort will instead return a different array. The original array won't be changed at all. They'll just give you back a separate array that's a sorted version of it. This one says that it's sorting in place, which means that that actual array will have been changed, right? So that's something that if we were writing test cases for this, that's part of our specification, we would want to test that. And we would want to do something like the original array gets sorted, not a separate array, right? And the test case for that, that's a little hard to write out here, your example, because the way that you would test that is more in code, where you would have something like, oh, I've got a pointer to my original array, and then there's another, then I can just, after I've called sorted, I can refer to my original array and see if the things are in the correct order that I would expect on that, right? So it's a little hard to write down this way. We'll see that again I'll be using these exact same examples for our test-driven development type of approach in the next class, where we actually start writing out the code for some of these. And that'll make a lot more sense, I think, at that point. But there was also on that first line another bit that's very specific about what this does that I think we would want to test. So it says it sorts the elements of an array in place, and then it also returns the array, which is interesting. It's a little interesting. You might say, like, do you need to do both of those? If you're sorting them in place, why do you need to return it? Yeah, I mean, there's an argument to be made there, but that's something else that we would want to test as well, right? Returns a reference to the original array. That's another one that'll make more sense in code for us to see, because what you would do there is, you were let's say I was writing this in code, you would have something like var, you know, letters equals BA, and then you would call something, you know, like then you would say like var letters sorted equals letters dot sort. And then you would want to check that, like, oh, letters sorted equals letters. So I want to make sure that those are both pointing at the same actual array. But those are some of the subtle specifications, bits of this specification that, you know, you have to read very carefully to make sure that you picked up. I don't know if there's much more on that one. Does anyone think of anything else? There are some considerations that you may want to have in the real world that we're not talking about. So if, for example, on a sort, you may want to have some considerations about limits, like, oh, it's going to throw an error if you try to have me sort an array that's, you know, 10 million items because I just can't handle that. Or you may have some specifications around how fast it can sort something. You may say, you should be able to sort an array of 1 million items in less than, you know, 10 seconds or something. Those may be some test cases that you would write in the real world for it, but we don't need to write those for, you know, our basic tests that we're doing here. Anyone think of any others? Think we're missing?
Sort is expected when given an array. The example would be like, if your array includes like Paul, Paula, Pauline, and like various names where it's just adding a suffix at the end of a word.
Those are good ones. Those are really good ones that you would probably want, right? Yeah. So you would have. And you would say like, well, let me switch these up a little bit, right? I want these to maybe be in some sort of mixed order here. And you would say what you expect. Oh, I expect this to give me back. And maybe you're not clear. Maybe you want to ask for more clarification on the specification. Like, I don't know. In this case, I'm going to assume that anything with more characters afterwards will sort after something else. But another case that's very similar would be ones where you've got the same, you know, up to a, I mean, I guess this is the exact same thing, but yeah, if you're the same up to a point, then you're going to want to sort based off, you know, the letter character farther down. So like Paula and Pauline, those aren't sorted that way because one's shorter than the other. They're sorted that way because A comes before I. But, and these are the types of things that as a developer, you need to be thinking about when you're writing your code. So this is why I think it's really useful to start talking about software testing right now, because as you start writing more complex pieces of code, one of the things that you should always be thinking about is, what are all of my edge cases? What does this actually need to deal with? How do I need to handle those in my code? And you want to be thinking about how you would test all of those different bits of behavior to make sure that they actually work correctly. All right. So what I did, again, I said I took the what we had as the exercise for trying to just think about what tools you would use to solve these different problems. And I want you to take this and turn it into an exercise. I took out some that didn't really apply very well. And there's still going to be some open-ended questions on some of these. Some of these I intentionally did not add any more specification. So if you start writing tests, you're probably going to say, I don't know enough about what to look for here. That's a little bit intentional on this. But I want you guys to tackle this, and I'll go ahead and just copy it up into Slack too as sort of the homework, which is look at each one of these and start thinking about what the tests would look like for each of these. What are the edge cases that you need to test? Are there any tricky scenarios that you need to account for? What are just some of the basic ones that you want to think about for each one of these? And what would be sort of the inputs and the outputs for those tests? We're going to be taking some of these and converting them into actual physical tests for some of these types of functions in the future. So be thinking about it hands-on practically as you're sort of working through that stuff. I'll go ahead and put that up into Slack real fast. Are there any questions on that? That's sort of the end of the material here, and then I can talk a little bit about the Git or GitHub issue dealing with remotes and the two different paths you can take there. All right, then let's talk about working with some remote project of some kind. I assume Daisy, look, I didn't even keep up. I assume Daisy posted a link to this project. All right. This is what she posted a link to? No. All right, it was this, right? I think there's still another one. What's that? Yeah.
It'll show the J case repository.
I'm sure it will. Oh, I'm in the gist section. Hold on. I've got this up here. It's probably an older one. There we go. So let's talk about how you would work with this stuff, right? I'm guessing what happened here when you ended up with the remote repo set up a certain way was you did something like this. You copied this link, and then, come on. You exist? All right, there we go. You get bigger for the screen, so it's up at the top. Where am I? I want to move down. This can be inside of Code the Dream, that's fine. And then you did, sorry for the, I need to fix this and then make that a to-do. I keep forgetting to change it to something more readable. You did like git clone, right? So now you have a clone of that repository and you can work with it. But if I go into that folder and I do git remote, I'll see my origin there. And if I do git remote -v, which is saying verbose, give me more details, I see that what's going on is my remote is still Daisy's source, right? And I don't have permission to push stuff into Daisy's repository. So if I am going to make some changes, let's see what we might do here. I don't know. I'm going to, let me open this up in my text editor.
She mentioned about changing something about CSS too, so you just change the colors.
Should have worked.
Why does GitHub work like that? It seems counterintuitive to work for a repository that all do having its AZ's repositories.
Well, the reason is it doesn't know what you do and don't have access to when you're cloning. It's all it knows is, I mean, let me be more clear. it knows that you have read access to it. It doesn't know that you don't have write access to it, because you wouldn't be able to clone it without read access, but it doesn't know that you can't write with your permissions. It's not checking your permissions at that point. So if you were, for example, working on a team and all of you are working out of the same repository, then you would clone that same repository and you would all have push access to it, so you could push your changes up. So multiple people would be able to push changes there. In this case, you're just working where you clone somebody else's stuff and now it's still pointing at it. So the way you can fix this, there's two ways more or less to fix this. This is the more difficult route. Let me go ahead and, like I said, let me make a change. Did that just not work? I really thought that would open up the editor correctly. Maybe it didn't because I have unsaved files here. Then I can close this. Let me see what will happen now. Try it one more time. You gonna go to the right folder? You just don't work correctly on my Mac. All right, fine. I'm just gonna do this because I don't need anything too complicated. Oh, dang it. It's wrong. JDK.css. What? I don't have them? What is going on? All right, fine. You know, I will have to open you up over here. Make a change. I'm going to Code the Dream, open JDK. Now I can make some sort of change. Like, let's change this CSS a little bit. I want my header font size to be 60 pixels. It doesn't matter. Just so that you guys can see a change. Now I can switch back to here. And if I do get status, we should see a modified file. As expected, I will add that modified file, get status, and I can see it, and I can commit it. I'll just give a message of increased header font size. If I look at my git log, my change is there because it is there on my local git, but it won't, I can't push it up because I don't have permission to write to that repository. So the problem now is that I need to have a repository that I do have permission to write to be able to work with. And the two ways to handle that are I can go here and I can choose to create a new repository. And maybe this one's just dated case new or something. You know, I can call it the same, but I'm using new and just because it'll save me a step in the future. And the easiest thing to do if I've done this approach is just not check anything else and just say create repository here. Because this will now give me some quick setup and it'll say, ooh, if you want to push an existing repository from the command line, here's how you do that. So what I can do is basically copy this. I want to remote add origin, and it's probably going to yell at me because it will tell me my origin already exists, and that's because I'm pointing at daisies. So first I need to, I can do it two ways. I can either modify it or delete it, I think. But if I delete, let me see, get remote remove, all right. So if I do get remote remove origin and then I looked at my get remote, I now don't have, it's a little low down there, but I don't have a remote anymore. And so now I could do get remote add. Oh, I already had all of that in there. Hold on. I literally just need to paste that. Now if I check, my origin is my own repository, and I should be able to push up to it. So that's the way to do it when you've already pulled something down, is you'll need to create a new repository for yourself, delete your remote. You can also change it, but delete it and then use those git commands to work with it. Now, the easier path, if you're doing this, is let's go back up to GitHub and do this the easier way. Instead of clone or download, I can say fork. And if I click this fork button, it'll give me, I'm in different organizations, so I can choose where my code will live. So let's say I say fork it into the Syrla one. It's going to take a moment, and this is going to fork it up on GitHub. So now I have a repository in my name for this. And now I can clone this one instead of the other one, and my remote will already be correct. So now my remote's going to be my remote because I forked it already up on GitHub instead of just copying it down from the remote repository. So that's the easier workflow, because then you don't have to go through and change any remote stuff. If you want to copy somebody's work and modify it in some way, using that fork button first is much easier than cloning it directly. Does that make sense? Yeah? And that's why I named the other one Jaden Case New, so that when I forked it, it didn't cause a problem, because it wanted to name it the same. Here. Any other questions about Git or GitHub? All right then. Anybody has any other questions, let me know. I can hang around a little bit afterwards, but I think we're done with class for today. The next class will probably be the test-driven development one. You know, as I finish writing that stuff out, I'll see how well I think that'll go over just remote. If I think it's going to be a little rough remote, then maybe I will choose to go over working with NPM and modules a little bit instead, which is the other topic that I want to cover in sort of that same time frame. Talk to everyone later on the video. Bye.